Okay. So here we have yesterday loops created, right? And definitely when we call loop in a method or create any class or object, do anything, right? So they are going to get called in a sequential way, right? Because it is unavoidable, because the call is happening sequentially and it will create one mother thread to start the execution, which is also called as execution path, right, where the actual execution happens. Now, so in order to create thread, so we have a class under system.threading class called something called a thread, right? Now we're going to create a thread class, creating object of thread class and point it to the method we are looking for. So here what we are looking, so anyways we know that this main method, whenever I start, it will create a thread. Now inside this thread, when I'm trying to create separate thread, right, and point it to some functionality, then this will create a separate execution path and both will go in parallel. Now we'll see that part. So MET1, I'll not call it separately. Let me just comment it out. And before this itself, I'll create thread. Let's say T1 is equal to new thread. And now here we have to provide a pointer. So where I'm gonna say new thread start of what is the target, right? Now this target is will always be a method, right? Kind of here I can give MET1. Sorry, it's going to be MET1 and close. Now this is your thread creation. Now which will come to your ready thread. As soon as you create this object of thread, right, with the target mentioned, this is in ready state, right? So now in order to start this thread, what we have to do? We have to go for start. So here we'll say T1 dot start. So now when we start this thread, which means a separate execution path will be created and this will start execution of this method, and it will still continue with the current thread. It will not stop here. Now this is something which creates a separate execution path or an asynchronous path to start with MET1, right? It will just kick off and it will continue to the current thread. It will not stop here till the thread is started and thread is completed and come back. No, it will not. Right, so that's what it is. So now you can see here when I say T1.start, which means this execution will start. What is this execution? This execution is nothing but a simple for loop. And a for loop, you can see here what we are doing in this for loop. So it will be in running state. Now intermittently we are actually taking it to pause state and getting back. And as soon as these iterations are done, right, which means as soon as iterations are done, what will happen? The for loop will be completed and it will come out. Which means it will come out of this method too. Now as soon as this method execution is done, that's it. It is aborted. That's your end of the thread, kind of. Right? So now this is your concept of thread you have. So let me run this program and see. Now you will be able to see your main thread and child thread, right, being executed in parallel. See, you can see here that you have main thread, child thread, main thread. You can see it's randomly printing, right? It's when we say randomly, right? It's actually the execution is happening parallel, which means my child method and the main method are running in parallel, and you can see that we are achieving the multi-threaded concept. So if you want to see the actual lag, we can actually provide some decent sleep time here, right? and run this program. So you can see here, okay, your main thread is running, your child thread, right? Which means with certain paths, both threads are going in parallel, right? So this is how we normally create a thread. And in this way, you can create any number of threads. It's not just one, right? So I've created one here. So I can extend this to multiple threads. Maybe I'll create one more method, but now let me create the method in separate class. Right, so let me create a separate class called class1. So in this class1, let me create a simple method. First, let me keep it here. But here, let me create public void. Maybe I'll say met2, for example. Open, close. And let's say here, I'm going to create a simple for loop of again 20 iterations. And then let's say I'm going to say console.writeLine. So this time I'll just give some pattern and I'll say class1 method kind of. And I'll print the iteration number. Okay, so I'm just creating this pattern so that we can see the differentiation. We're going to call this method in a separate thread so that I want even met2, which means my met1, met2, and the current program in my main should run in parallel. That's my mode, right? So now let me create a separate thread, which is my thread, right, t2, let's say, as my new thread of new thread start. So now I have to provide a target, right? Now what is going to be target? The target is my object in my class 1. That's my target. So before this, what I'll do, I can create class 1 object. Maybe let's say obj is equal to new object. And here you see obj dot met2. Okay. So now T2, right, is referring to this. Now, anyways, when you are giving target, you should not give it as method. You should give it as a invocation. Now here, this is your trigger. So once your trigger is created, then you can say T2.start, which means you are actually starting up your second thread, right? So in second thread, we see there is no sleep as such. So let's create that, which is your thread dot sleep of maybe let's say 5 milliseconds again, and let me run this program. Now you can see all the three are running in parallel. Your main thread, child thread, and class 1 method. Main thread, child thread, and class 1 method are almost like they're running in parallel. You can see as the sleep time is same, right? So when we say sleep time, it's a pause time. Pause time is same. That's why you're able to actually see all the executions, all the three executions happening at one shot. Right? So this is all about the creation of threading, right? How we normally do create and do actually make sure the threads are working across, right? So this is one how we normally create threads. And now going to advanced one. So let's say I have one more method here called met3. And this method is right. What it is doing? It is again printing the same console.out. So let me give some other pattern to this. So with this itself we can understand, because I'm trying to create an infinite thread. Infinite loop first. Let's say long L is equal to 0. I'm taking and I want to print L. L is This is my method. So these kind of infinite situations you will definitely encounter. When you basically start with Windows-based applications or writing a service, right? So now, so here in this situation, right, when you're actually creating infinite. So let me just give a small pause here, so that I have a thread dot sleep of, let me give some just 200 milliseconds pause, or maybe 400 milliseconds pause. And for this method, what I'm going to do, I'm going to create next thread. T3 as new thread of new thread start obj dot your med3, and then say do dot start. So now here you can see this is going to be, so okay, so you have the class. Is there any issue here? Oh, sorry, I'm using the same, I'm trying to start the same thread, which is not correct. My mistake, I have to make it as T3, right? I can't start already started thread, so I should have done it T3, that's right, yeah. Now you can see here, infinite thread is running. So class 1, main 1, it will run in parallel to others. So once other threads are, see, you can see that other threads are closed or aborted or stopped, because they have finite set of instructions to run, and as soon as finite set of instructions are executed, right, it will stop that set automatically. And you can see with infinite thread there is no stop here. Why? Because we haven't created any finite set of instructions here. Now this will go infinite because we are allowing it to go infinite using a for loop, right? Now here, which means in this thread what we have done, we are running a thread and we are pausing the thread. It's coming back from pause and again, right, it's coming back to the execution part again. Right? So that's why, right, in this situation we have to plan for how to abort, or in what situations you want to abort, or we can take a call on how you want to actually check on aborting this. Right? Now this is where I was actually checking out to when we say aborting this, right? Now I can abruptly stop this thread, but as of now what we are doing in this thread, we are just printing some stuff and having a pause, right? But in real time what will happen, so if you take it in real time, right, you will have so many transactions been happening. Like let's say DB updates are going on, right? Once DB update is done, one table you are updating. Based on that table update, 10 different tables are getting updated. Let's say there are some 100 different steps happening. So when I stop this thread immediately or abruptly, it may lose the logical completion of one full transaction. So there is a possibility of, right, missing the transaction update, right, which definitely will not be will not be good to do. So in these situations we always have to plan for a logical closure, right, or some logical closure of your thread. So let me show you one type of logical closure that we can actually use this situation can can arise anytime to create to actually create an infinite threads. So definitely you can see once you're creating an open-ended infinite loop, so definitely it means that this method is never going to end. Why? Because it always be in this loop. So that's why we can also call this as an infinite thread, which never stops. Infinite service thread. Now this is how it goes, right? So if we see the WebEx which we are using now, right? It should not stop until I close the application, right? Now it should continuously broadcast the voice, right? It should continuously broadcast the screen, right? So every movement in the screen, every piece of code, every piece of letter I'm typing in here should get broadcasted, right? So which means there is no closure to it. It will always go until I close my application. So when I say closing my application, which means I'm killing all the threads, right? And so on. Right? So closing all the threads and everything is like closing them in a logical manner. Now let us see how we can actually apply it. Okay, so a thread is running on which is T3 here. So let me just stop this execution. Right? And it's an infinite loop which is running. So in this situation what we can do, right? So for example, let's say I can have a flag, let's say public boolean, right, is active, for example. This is my flag which is always true, for example. Whenever I create any new pointer, let's say new object to point to this, right, it will always be true, for example. So here what I'm doing, I'm checking in this loop saying if is active is not true, then I'll say break. What is this break? Break is like coming out of this one, which means see, after logical set of my statements, what I'm doing, okay, fine. I'm gonna check a flag here saying, okay, if it is active, then okay. But if it is not active, then break it. Breaking in the sense coming out of my infinite loop. What is the meaning of coming out of infinite loop? Which means, right, it will have a logical closure and it will come out of my method. As soon as it comes out of my method, the thread is anyways exposed. Right? So here what we are going to do, anyway, see, you can see here till this flag is true. Now this will never stop, right? So for example here, let's say I have started my T3 and anyways I left my current current execution of main, and then let's say I'm gonna give some thread stop to the current main method, sleep of let's say 1000 milliseconds, for example, right? And then I'll say obj is nothing but my class object, right? Dot is active is equal to false, which means after my main thread is completed, right? Wait for a second, right? Or wait for maybe 2 seconds, right? And then make it fast. See, I'm not even touching. See what I can do. I can say T3 dot abort. I have a direct method to kill the thread, but it is not recommended to actually go for abort if you are doing any logical transactions. See now, so when I run my program, it all depends on my main method now. See, main method things are running. Main method is still going on. Main method 19. Okay, so main method is done. See, closed. As soon as main method is done, it just waited for like 2 seconds, almost 2 seconds, and that's it. It made false. See, I'm not doing any force stop here. I'm stopping everything in a logical manner. Now this is how we should always abort a logical running thread. Right? Now in this way, transactions will never be disturbed, right? And whatever piece of code you're actually writing in between will always be. So So next step is, for example, what if, let's say I'm going to take int x is equal to some 10 divided by, let's say, L, or I'll say L minus 10, for example. What will happen? Right? Okay, it's long. It's fine. That's fine. That's fine. Anything. But here, the main intention here is, I want to crash this loop, or rather crash this because of some logical issue, right? So when I run my program here, so when thread infinite thread equals 10 comes to 10, so 10 minus 10 will become 0, and then that's it. It again give you attempt 0. So what will happen now? See, when I continue it, right, it will not stop, which means this is going to crash my application, right? So it may either crash my application or crash the complete thread without even running. Now, always in these situations, always exception handling within the scope is important. So let's say here, what I'm going to do, I'm going to take try catch, and if any exception happens, let's say I'm going to say continue, for example, which means, okay, if any exception happens, that's fine, continue the loop, at least continue to the next transactions, log it up here, right? If you have any exception, let's say for example, log here console dot write line of exception happened so and so, and then print up ex dot message, and then move on, right? So now when you see I am running it, so it's going on thread 3, 5, 7, 8, 9, see, and now, okay, now there is a problem here. I'll tell you what. See, it will always give you exception happened and attempt to divide by 0. But loop is still running, honestly. Why it is not moving on, you can see here, we are doing L++ here, right? Which means L becomes 10, some other time will become 10, and it always says 10 because next time when it is coming over here, this program is not even getting triggered, right? So these type of things should be done here. So here what I'm going to do, I'm going to use finally here and I'll say L++. This is the best example where I can show you, right, what can be done. See, whether exception happens or not happens doesn't matter at all to me. What is important? I have to move on. In order to move on, what is required? It is required to increase my, let's say maybe it's my iteration variable, for example, I'm increasing it. Simple as that. So when I run this program, thread 8, 9 to see, error once came, and that's why you won't be able to see the 10, right? But that's why after 10, anyways, it continued, let me just show you. So after 9, value was 10, it actually went for a toss, right? And as soon as error happened, it absorbed the error, so we logged it and everything is done, and the next iteration started. So this is how we can check. Right? And also, even this one, maybe if you feel this is important, which is checking of, right, activeness or not, you can always do the stuff again, like maybe outside your exception handling itself, because okay, this is fine, but apart from this, I don't want to, get this into a conditional mode. I should always execute this for every iteration. And anyway, this is not never going to be error out because it is active, is a active boolean variable I have in my class. So this is how we normally handle the fittings here. So any questions, guys? Fine, perfect. And now sometimes you may get a situation where you may have to see among all these threads, right? I don't know which thread is running where and so on, which thread is running on priority and all, right? So for that we have few priorities which are important, which you can assign to any thread. Let's say for example T1 thread, I want to set priority, sorry, right? I have, right, these type of priorities. I have above normal. So by default, right, by default you can see normal is the one which is a default default priority we have for any thread, right? So this is a default priority we have always. So here, if you want to change the priority, now what is the priority? Priority is nothing but when you change the set priority. See, as I said, when you are using Word, Microsoft Word, right? What is the highest priority for running Word? It's, we know that it's a typing, right? Typing is one of like method. Let's say MET is the one which provides functionality to type, right? So this method will always be of high priority, right? Similarly, some methods, let's say grammar check maybe or other thing, as when compared to typing, let's say for example is lowest priority, right? Then you can mention that as a lowest priority using your priority attribute, right? So similarly, you can also name your let's say I'm going to keep it normal itself. You can also name your threads, which is like T1 dot, I'll say name. Maybe I'll say it as thread 1. Right? Now this thread, whenever I'm actually running this, right, I can actually print this thread, which thread output is this kind of. Right? So in order to do, so what I can do here, I can say in my thread dot, I have a property called current thread dot name. Simple. Now this will give us a name of the thread. Now you can assign name to each and every thread. So when I run this program, we will be able to see the name. See, thread 1 child, what is that? Thread 1 child MED1. Right? Yes, thread 1 child. So this way, you can actually assign your thread names here. Right? Sometimes what will happen, multiple threads will be triggering one single method. For example, let's say this MET2 is a method, one single method where multiple threads are hitting us. As a T2 is referring to MET2. Maybe tomorrow 3 more threads will be created to actually take this MET2 into separate execution path and start executing. But end of the day, let's say if they are actually using single object for using this method, right, there is going to be a problem because it may kill the previous execution we have, right? So in this situation, right, whenever you have a situation of actually creating it separately, right? So we are not going to create, let's say if I want to use 3 different sets the same method, right? I can't create the same method 3 times, right? Now which is not logically correct, right? You should always go for methods where I can actually mark it in a single signature and use it in multiple ways, right? So, but multiple executions may kill this. So for that reason, what we can do, we can lock this method for every thread. Let's say 3 threads are mounting on it. So what we can do until one thread execution is done, right? We can keep other threads in wait. In order to do that, what we can do, you can lock this. Locking is possible in this way. So what we can do, we can use something called mutex. So mutex is a class which can be used to lock certain piece of code, and it will not allow other executions to happen until you unlock it. Let's say m is equal to new mutex, for example, and I'll say m dot, right? So here we have a property called wait1. So this will start your lock. So we are locking it. And as soon as you're done with execution, I'm gonna say m dot release mutex. This will release the mutex. Right? So here you can see you may not be able to feed it here, because even if you're calling, because it's a quick 20 iteration method. But if you go for a heavy logical thing, like locking process is safe, locking your thread process is safe. So no issues for this locking. So here, but the best way to use this is, whenever you're creating any mutex, always make sure that whenever you're actually creating your waiting, always make sure you're locking up at the first step of your try, and then even if exception happens or not, make sure that we are writing the release of mutex in finally only, right? Because if any exception happens, and if you are not releasing the mutex, then that's it. This method will never be able to access by anyone else, right? So that's a problem going to be. Fine. So that's why we have something called releasing the mutex. So this is you can use it whenever you want to lock and kind of unlock the methods if you are actually using it in a multiple threads. So this is all about a threading concept we have, right, in C#, and we are left with collections. So collections we're gonna need tomorrow's class, and we'll wind up our collection.